All right, we're starting at number 8. See, I'm on my comfy mode, comfy jacket. Use trapezoids to the right to approximate the integration from 1 to 7. So there's 3 trapezoids. You just do each one. Now you should do this in your notebook and write this down and then write down the answer. Oh, there's a fly there. So the first trapezoid, we start with 1/2, the width, and then we add the heights. So 1 plus 3. That's it. The width, and then add the height. So that's 3 plus 2. And then the width is 3. And the height is what? 2 plus 1. That's it. Okay, next. Number 9. Again, press pause, try it first, then press play. Here's a challenging looking function inside here that we're integrating from -3 to 5 using the 4 regions is labeled below. First, a Riemann sum with left-hand rectangles. So when it's like this, they're not an equal width. So you have to take the size that's given and each one separately. So from -3 to 0, the width is 3. And then to find the height, use the left value and plug it in. So it's the cube root of -3, subtract 1/2. And then let it go. The next one. It goes 0 to 1. That's a width of 1. And then you plug in 0. The next one is 1 to 2. And you plug in 1. The next one is 2 to 5. And you plug in 3. 2. The left one. For trapezoids, there's not an equal width. So when you take what's given in terms of each trapezoid, so the width, so it starts with 1/2. The width is 3. The first height, you would plug in -3. Plus the second height, you'd plug in 0. But you'd have to do that for each one. I'm probably going to run out of space. But 1/2, and then the next width is 1, and then you plug in 0, and then you plug in 1 for the 2 heights. The next one again is 1. So it's 1/2 times 1, and then plug in 1 and then 2. I'm just going to keep going down here. Plug in, the width is 3. And then you plug in 2. And you plug in 5. A little more tedious, right, when they're not an equal width. Just recognize the formula that you're doing. 1/2 the width, and then you add the 2 heights. That's it. In number 10, you have a table of values. I'm going to put the answer underneath there again. You don't need to write this table down. Just in your notebook, write down 10, write this down, and then the answer. I'm going to put the answer down here. So I'm integrating from 2 to 4. We have 4 equal subdivisions. So step 1 is to find the width. So it's going to be the top bound subtract the bottom bound divided by 4. That gives me the answer 2 over 4, or 1/2. So the width of each trapezoid is 1/2. So the answer starts with 1/2. That's the formula. The width, which is 1/2. And then the height. So the first height I use is 4.12. But I'm counting by halves. So the next half is here at 2.5. That's the next height, and I double it. And again, I'm going to double. I'm going to count again by half and double. Count again by half and double. And then again by half, and don't double the first one or the last one. Done. For number 11, you're trying to approximate the area of this lake. You should try to do it first and then press play. But if you tried first using trapezoids, equal width, they are 20. So the formula is 1/2, and then the width is 20. The first height is 55. Then I double 63. I double 81, I double 86, I double 106, I double 118, I double 98, I double 57, and now this is where it gets a little bit, not too tricky, but 47 is not the end of the lake. Right here is the end of the lake. So 47 is not the end. So I still double 47. The very end that you don't see, the last height is 0. And that would give me the approximate area of that lake using trapezoids. So the trick was at the end to recognize 47 is not the last height. This is the last height. Turn the page. Press pause and try it first. Number 12, it says, use the trapezoidal rule. We're going to integrate from 0 to 4 the square root of x squared plus 1. And it says to draw an accurate graph as best as possible. So I'm going to count to 4. And then I recognize that if I plug in 0, the answer is 1. And if I plug in 4, it's the square root of 17, which is a little bit bigger than 4. And then my trapezoids are in equal width, 4 of them. So it's the top subtract the bottom divided by 4. So there's my trapezoid, there's my trapezoid, my trapezoid, my trapezoid, and then I find the area of each one. So it starts with 1/2, the width is 1. The first height is 1, then I double the second one by plugging in 1. Then I plug in 2, then I plug in 3, and then I plug in 4, but the square root of 17, the first height and the last height are singular, and you double the middle heights. Number 13, use a calculator. I like that. So let me write it down. For if f at x equals ln x, what's the second derivative at 2? How would I figure that out? So the second derivative of 2. So let's do it together. Let's see if you can do that, right? Try it first with your calculator. Press pause. And so if I want to find the second derivative, where do I go on the calculator? See if I can make it a little less blurry. Menu, calculus, derivative at a point. X is our variable. The value is at 2. Now here we change this to the second derivative and then press enter twice. And now you just plug in ln x. Ln is right here in blue. So press control and then e to the x for ln. And that's it. Go control enter. Let's see if it stays blurry. And you get negative 0.25. 14. Find the area between the function e to the x and the x-axis from the interval from 0 to 2. So the idea is that we're to find area, we integrate, and we're going to integrate e to the x from 0 to 2, and then we're going to let the calculator find the area for us. So menu calculus integral, and it's from 0 to 2. Now make sure that when you go e, it's not at the bottom of your calculator. Use the e here on the left. So e to the x dx. I keep getting blurry here. And then control enter, and it's 6.389. Number 15, use the graph at the right. All right, so that's curved and then a line. And then do the following. So graph each one. Sorry, this is not 15 yet. That's just what's in the question. So 15 says y equals negative f at x plus 1. And how would I regraph that? What do those changes do to the graph? So this negative reflects it down. So all the y values that are positive become negative, and negative becomes positive. And then I'm shifting 1 up. So if I start with this point, since it's on the axes, it can't reflect up, so it just goes up 1. There it is. And there's the new point. For this one, it gets reflected down and then up 1. And then this is like a semicircle, a quarter of a circle. And now I'm just going to take this point, same idea. If I just take, because it's a line segment, I just need to change the end point and then connect it, and everything else works. So I'm going to reflect it up to 2 and then up 1 from there. So it goes to 3. So 1, 2, 3, 4, up to 3, and then you have it. Okay, number 16, absolute value. So absolute value makes everything positive, and then you shift it 1 to the left. So this is 0, so it stays 0. So shift it 1 to the left, so it stays there. Here, this is already positive, so shift it 1 to the left, and then connect this. This is important because this bottom part is that way. All right, 1 second. Awesome, thank you. I appreciate it. All right, I'm back. Sorry, where was I? Shift it 1 to this point here. Shift it 1 to the left. Here, this point gets reflected up, so it becomes positive 2, and then 1 to the left. There it is. Number 17, I have room. For number 17, there's a vertical stretch and a reflection. So we're going to multiply it times 2. So this, the 0 times 2 stays 0. And the reflection is across this way. So this becomes to the right. This point here times 2 becomes 4, but it stays on the axes. Reflection, and that's going to be curved. And then I'm just going to take this point here at the end. What am I doing again? Times 2 becomes negative 4. And then reflect it. So 4 to the left, and then 4 down. And that's what it looks like. The line has an arrow at the end, doesn't it? So you gotta make sure there's arrows at the end. I didn't do this one accurate here like that. All right, number 18. It says evaluate. This is called the fundamental rule of calculus. So the derivative and integration undo each other. It's ultimately a substitution question. And if there's a hook, so we substitute in, and then the derivative of x is 1, so there's no hook. When I substitute in the bottom bound and take the derivative, it would be 0. So I don't need that. That's it, done. Number 19, again, the fundamental theorem of calculus. Order matters. And so when I plug in 0 and take the derivative, I need 0 to start with, subtract, and then you substitute in, and then the derivative of the hook is your hook at the end. So it's just substitute in, and then the derivative of the bound is your hook. Number 20. Substitute in, and then the derivative of the hook is that. When I plug in 0 and take the derivative, I don't need to go subtract 0. 21. This is not a fundamental theory of calculus because you're not taking the derivative, so you just have to actually integrate it. So I'm going to make it calculus friendly. And then to integrate, it's just the power rule. So I'm going to add 1 to the exponent, and then divide or times the reciprocal, and then I'm integrating from 0 to x, and then you plug in x, and then you plug in 0. Now when you do plug in 0, all this is 0, so you don't really need to go subtract 0 at the end. Uh, 22. In 22, set up an integral which could be used to find the areas of what's described. You do not need to evaluate it and so on. So I see symmetry here, so I only need to integrate from 0 to 3 and double it, and it's 2x to the 2/3 dx, and there it is, done. That would find the complete area. Region bounded by y squared plus 1 from 0, -2, and then 3. So let me just tell you what y squared plus 1 looks like. It's a sideways parabola, and then if you plug in 0 for y, x is 1. It's like that. But anyway, this is what it looks like. And so if it's bounded by x equals 0, y equals 3, and y equals -2, it's this area here that we would be finding. And so you'd use the y values. So you go from -2, so from -2 to 3, and then it would be this, just y squared plus 1 dy. That would find the area here, between here and the y-axis. I know it's a little bit confusing when it's not a function. Number 24. Without a calculator, sketch graphs, use geometry to evaluate. All right, let's do that over here. So I'm going to integrate from 0 to 4 the absolute value of 3x minus 2 dx. So using geometry, first of all, I know the picture looks like a V. So I'm going to take 3x subtract 2 and make it equal to 0 to find this vertex where the V is. So I'm going to add 2 and divide. So at 2/3 we have that vertex. So at 2/3 we have that vertex. When I plug in 0, the answer is 2. When I plug in 4, 12 take away 2 is 10. So up here is 10. I just need the height and so on. So I just need to find the area of each triangle. So the first triangle, half the base times the height. And then the second triangle, half the base. Now be careful here. So this is 3 and 1/3. Can you think that through? So this is 3 and 1/3. That's the base, and then the height is 10. Now I don't need to simplify it. 25. To graph this, absolute value of x, it's been reflected and up to. So I go up to, and this is where the vertex is at 0 and 2. Plug in -2. The absolute value of -2 is 2, and 2 take away 2 is 0. And then plug in 1, and the absolute value of 1 is 1. 2 take away 1 is 1. So 1, 1. So this is what I'm finding the area of. Look carefully. It's a trapezoid and a triangle. So we're going to do the triangle on the left, half the base times the height. The trapezoid on the right, half the width, and then the two heights. So the first height is 2 and 1. And there it is. 26. Press pause and try first, please. A spherical balloon is expanding at a rate of 5 centimeters cubed per second. How fast is the diameter of the balloon increasing when its volume is 36 centimeters cubed? So I'm going to break it down. I have a formula to start with. I only have one variable on the right, so I'm ready to go. I'm going to take the derivative. So 3 times 4/3 is just 4, and subtract 1 to the exponent, but it needs a hook, dr by dt. In the question it says the volume is increasing by, so dv by dt is 5. If the volume is 36 pi centimeters cubed, I need to find the radius. So that's the volume. So I'm going to multiply by the reciprocal. So that's 3 times 9, 27. The cube root of 27 is actually 3. So it actually ends up being a nice number. So the radius is 3. So I'm going to plug that in. So this is 9 times 4. So when I divide it, it's 36 pi. So the radius is increasing by that much. Recognize that the diameter is twice the radius. So when I take the derivative, dr by dt here, it's 5 over 36 pi. And that's the answer. And I need a unit. So it is centimeters per second. A little tricky, right? That's how fast the diameter. So the first part might be kind of simple, but then you still need to see the relationship between the diameter and the radius and take the derivative of that and plug in your answer into that. So good, solid. That's a tier 1 question right there. 27. Turn the page. I'm just going to do it right off here. So here you have velocity. This is a rate graph of a car during a 10-minute factory test drive along a straight path. So it's just going in one direction. Or one, in terms of the path, it's just straight there. So when it's below, it's going backwards, and when it's above, it's going forward. So what interval was the car moving backwards? So between 0 and 2 seconds, because the velocity is negative. Or is it minutes? Minutes. All right, I'm going to have to write it down here. So reverse was between 0 and 2 minutes. When is it forward? So when is it above? It's from 3 to 10. These really should be parentheses. And then what is it at rest? Is between 2 and 3. That's when it's 0. It's not that it's a flat line, but that it is 0. So when the velocity is 0, it's resting. So it goes backwards, it rests, and then forward. That's A. B, what does point A represent? So at what time? At 6 minutes, the car is moving at a rate of 6,000 feet per minute. I know it's sloppy, I'm sorry. C, find the speed of the car. So speed is the absolute value. So whatever the positive value is. So at 1, it'd be positive 1,000 feet. When t equals 2, the speed at 2, it's 0. And then the speed at 4, looking off the graph, right here, it's 2,000. That one would be the speed and velocity would be the same because it's positive. Find the acceleration between 3 and 6. Acceleration is the slope of the velocity. So what's the slope of this line? So rise 6,000 over 3. And that is in feet per minute per minute. And yes, you could simplify it to 2,000, but you don't have to. E, on what time interval is the acceleration the greatest? So the acceleration's the greatest between 3 and 6, right? Yeah. So the acceleration's negative, the acceleration's positive, but it's just up 1 over 1. Here, the acceleration, and then no acceleration's constant, and then negative. So this is where it has the greatest positive number. F, on what interval is the absolute value of the car's acceleration the greatest? Well, that's between 9 and 10. So if you take the absolute value, that slope becomes positive, and this is the steepest part of it. G, on what time is the Lion King, is the car speeding up? So the car is speeding up when the signs are the same. And so here at the beginning, it's negative velocity with a negative acceleration. So between 0 and 1, it's speeding up. Here, it's positive and above. So a positive slope and positive. So between 3 and 6, it's speeding up. And that's it. Everywhere else, the signs are wrong or 0. So between 0 and 1 and 3 to 6, it's speeding up. So we're looking for when the velocity and acceleration have the same sign. They both are negative or they're both positive. H. Integrate from 0 to 10, the velocity. So if I integrate this, this is a triangle and this is a trapezoid. So this triangle, half the base and then the height is negative 1,000. And then the trapezoid, the width is 7. So it's 1/2 times 7. The first height is 6,000. And the second height is... Oh, the trapezoid's been flipped around. So let's try it again. So we have to think of it as the height. So the height of it, so half the height, basis times the height. So let's try this again. So because the trapezoid is flipped around, this is not the width. This is it right here. So now we have to think of it as height and basis. So that's 6,000. And then the two widths or bases are 7. And then from 6 to 9. So that's 3. So the trapezoid got reorientated, pointing sideways again rather than up. So it wasn't like the trapezoidal rule. So you just have to think of the way the trapezoid was sitting on the graph. If you simplified that, you would get the answer. I'll do it for you, 29,000 feet. And then it says, find the absolute value of that. So the absolute value of what I just did would mean all values would be positive. So this here would be positive, right? It'd be positive. So you'd add 1,000 instead of that. So it'd end up being 31,000. So if this becomes a positive number and you add it all up, it'd be 31,000. J, write a sentence saying what does the first one mean. So the total distance, not the total distance. It's the displacement. J is the displacement. The displacement of the car from 0 to 10 minutes is 29,000 feet. Well, K is the total distance it traveled. and it's 31,000 feet. So absolute value gives you total distance. Otherwise, it's called displacement. The very last one, L. If the initial position was 5,000 feet, what is the position of the car at 10 minutes? So this is basically what you're doing. So the initial position, and then after 10 minutes, what's happened? So all you would have to do is add 29,000 to it and say, oh, now the position of it is at 34,000 feet. All right, 28. The product of two numbers is 80. Find the numbers of the sum of the first and 5 times the second is a minimum. So you have a choice. I'm going to let x equal 80 over y. I'm going to plug that in, but write it as 80y to the negative 1. Now I have one variable. Take the derivative of this and then make it equal to 0 and then solve it. So I'm going to add this to the right side and make it a fraction. I'm going to multiply by y squared. When you divide by 5, the answer is 16. So when you take the square root, the answer is positive or negative, but it says two positive numbers. So y is 4, and then 80 divided by 4, x is 20. Sorry. Number 29, last one. You're integrating from 0 to 2, f of x dx equals 4. It's an odd function. So think of an odd function like a cube function, right? Where this area matches this area. That would be 0 because one's positive and negative in terms of symmetry. So from 0 to 2, if this is 4, that's what we're going to visualize. So from negative 2 to 0, it would be negative 4. So from 0 to negative 2, that number would match but be negative. From negative 2 to positive 2, if it's an odd function, so that means positive 4 and negative 4 makes it 0. From 0 to 2, negative f of x dx. So take the answer 4 and make it negative. D. From 0 to 2, 3 f of x dx. Take the answer times 3. So 4 times 3, and then the last one, then we're done. Be careful of this one because we have to separate it into 2. So there's one and there's the other one. So the first answer to evaluate from 0 to 2, f of x, that answer is 4. And then the second one, we don't need the graph, just do it. So what's the integration of 1 is x, and you plug in from 0 to 2. So if I plug in 2, subtract, plug in 0, that answer is 2. So when I add it, the answer is 6. That's it. Mr. G Math over and out. I'm proud of you for doing your work. Until next time.